I love math. I love math.
Guys, I just wanted to show you guys a roadmap of where we've been. Types of statistics, we have data. In green, though, we've already done that. We've had the population available to us. We've done one variable stats, whether they are graphs or numbers or normal distributions. We've also done two variable stats, quantitative with scatter plots, linear regression, exponential, and we've done some power regression. We have not done two-way tables, which we will do when we do probability in Chapter 4. Sometimes in data, the population is not available to us, so we have to keep taking surveys and sampling, and we produce data where we either have experiments or sampling distributions. So that's just a quick peek of where we've been. All right, let's go over lesson 3.6, observational studies and experiments. In our learning target, something a little bit different. I added learning target 0 because it's technically kind of like not in the book, but super helpful during this time. How to understand experimental design and its vocabulary. So that's what we're going to do. Learning target number 1, explain the concept of confounding and how it limits the ability to make cause and effect conclusions. Learning target number 3, explain the purpose of comparison in an experiment. And learning target number 3, describe the placebo effect and the purpose of blinding in an experiment. Okay, so let's do learning target number 0. Sounds kind of weird. And concerning this weird situation here, let's just say I have some really cool new rabbit food. We'll call this new. And of course, you always compared it to the old. And what's awesome about this new rabbit food, this hippity hop, it makes the rabbits' fur soft and shiny, increases their energy, 100% of their daily vitamins, and essentially oils. Okay, question. Can I make these claims? No, you can't, because you're just kind of just saying a bunch of stuff, but no facts, right? What must I do to make these kind of claims? Well, you're going to have to do an experiment. Who or what should I test this on? Well, who's this for? It's for rabbits. And what do I test? I'm going to test the type of food. The type of food. Okay, so I have some terminology there in the next boxes below. The experimental unit is the single individual, it could be a person, animal, plant, or thing, to which the different treatments are assigned. Okay, there's also the response variable. If you remember back, the response variable is a response variable measures an outcome of a study. How does it respond? This one down here this one is called the explanatory. Do you guys remember this one? This one does may help predict or explain. Like that was our X, and response was the put this over here, was the Y variable. Does X cause the Y? And the last one, a treatment, is a specific experimental condition applied to the unit's treatment. Let's do a couple examples, and this might make sense. Identify the experimental units or subjects, the factors, the treatments, and the response variables for the experimental situation below. Example 0A. In this 2-year trial, we randomly assigned 322 moderately obese subjects. So the mean or average age is 52 years old. What does it mean to be moderately obese? You use the body mass index, BMI, where the weight in kilograms or pounds is divided by the square of the height in meters or inches. And I guess the rating for the BMI index would be 31. We have males that are male gender, so 86% of the 322 are male. And we're giving these one of the three diets. Low fat, restricted calories, So low fat, restricted calorie, that's 1. 2 is the Mediterranean restricted calorie, and 3 is the low carbohydrate, non-restricted calories, okay? All right, what are the experimental units in this problem? They are the people participating in the diets. People participating in the diet or the trial. If you guys didn't know, you can actually get paid to be an experimental unit. What is the response variable? How do people respond? Well, we're just going to figure out if they lose weight, whoops. So these are the results. That was the word I wanted to have. Results. So if they lose weight, or and their level of cholesterol. What are the treatments? These are the 3 types of diets. And what is the explanatory variable? What explains what is happening? You can also say the 3 types of diets. Now, there's a bunch of other factors that can go into this. How can someone else, so this is what we need to think about. How else could someone lose weight and level of cholesterol? Is it just what they eat? No, it can be other things like genetics, maybe stress. That's what I'm thinking, right? Exercise, sleep. It can also be their diet. Okay? Go ahead and press pause and go ahead and try example 0A. I skipped that one. About the new rabbit food, and then press play when you're ready. All right, so let's go over example 0A. I plan to test my new rabbit food. What are our experimental units? Who are we testing this on? We are testing this on rabbits. What is the response variable? What are the, remember the R, what are the results from the study? It can be how well they grow. Right, their fur, how soft it is. Explanatory variable was the type of food. And the treatments, this can be the amount of food. I don't know anything about rabbits. So maybe treatment number 1, you give them, I guess it's kind of mean, not very ethical. If I give them, I don't know, maybe you feed them like 4 times a day. Feed them 4 times a day rather than 3 times a day with less food. I don't know, 3 ounces, so it equals, I don't know, 12 ounces a day. Or maybe you feed them 3 times a day at 4 ounces, so you're still getting 12 ounces of food. Or you feed them twice, but you give them really big amounts of this new amount of food. So you can kind of compare about how much. Okay? All right, let's try page 2 now. All right, we got to fill out the bottom here. The only way to show cause and effect is with a well-designed, well-controlled experiment. So the researcher has to do something actively, okay? All right. So if we go to the top of page 2, which will probably be in the page 1 once I finish editing, again, what is the only way to show cause and effect? This is with a well-designed, well-controlled experiment. Okay, that was learning target, 0. Let's go on to learning target number 1. Explain the concept of confounding. Confounding. And how it limits the ability to make a cause and effect conclusions. Number 1, the word confounding occurs when 2 variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. Right? So maybe an easy example might be, or another word for confounding might be kind of like confusing. So for example, let's just say you lock yourself in your room and then the next day you get a really high test score. What is the variable that got you the high test scores? Well, what did you do inside your room? Most people would think, oh, studying. But what happens if you locked your room because you slept and you did better? Or if you played video games or you're talking to your friend? Those are a bunch of different confounding variables that help you got the high test score when they're not quite sure. They would have to do an experiment. Okay, let's do this example here. Example 1a. Should women take hormones such as estrogen after menopause, when natural production of these hormones ends? In 1992, many medical organizations said yes. Women who took hormones seemed to reduce their risk of heart attack by 35 to 50%. The evidence came from comparing many women who took hormones with others who were not. Okay, what type of study is this? Question, did researchers do anything? It could sound like, the researchers were saying one group take hormones, one group don't take hormones, but it doesn't say that, right? So this would be an observational. They're just observing, they're just watching. Okay, this is not a what? This is not a experiment because there was no did not give or give hormones. Right? A researcher has to kind of intervene on that, right? What is the explanatory variable? Hormones. Yes or no? Did they give it to them? Okay, what is the response? What is the results? They wanted to know really about the heart attacks. Heart attacks. Okay. What other variables might affect this study? What else can reduce someone's heart attack? ability. Like, you don't want it. Well, maybe it's their education. Maybe it's their age. Maybe it is their health. They're in good health or bad health. Maybe their body awareness. Maybe how much money they have and their ability to have access to good health care. All right, so let's just draw a quick picture, and this might make more sense to you. Okay, what was the explanatory variable? It was hormones. And we were kind of hoping that the explanatory variable would explain the RV, the response variable, which was less heart attacks. But what we just talked about is in all of these here in some kind of green, like income, this could actually affect the response variable, and it's not necessarily the hormones, or maybe it is doctor visits. We're not sure if that decreases the person's chances of getting a heart attack. That's why it's confounding or kind of confusing, okay? All right, why don't you go ahead and press pause and complete example 1B, and then I'll show you guys my answer. All right, example 1B says, does happiness prevent heart disease? In a study of random sample of 1,739 adults from Nova Scotia, Canada, researchers interviewed each participant and, among other variables, assessed their attitude using a formal psychological survey. It was found that adults who had more positive attitude were less likely than their peers to have coronary heart disease over a 10-year period. Based on the study, is it reasonable to conclude that a positive attitude causes a decrease in the risk of coronary heart disease in adults in Nova Scotia? Explain. Not necessarily. Although a positive attitude may decrease the risk of coronary heart disease, it is possible that those Nova Scotians who had a more positive attitude were more likely to exercise regularly. Perhaps it was the regular exercise that caused a decrease in the risk of coronary heart disease and not the positive attitude. Again, you're going to need to use your critical thinking, and that doesn't tell us about exercise, but you're going to have to kind of know just what can cause someone to have better heart health, diet, what you eat, how often you eat, what you eat, exercise, maybe not smoking or drinking. There's a bunch of other things that can happen. Okay? All right. Let's move on to learning target number 2, sorry. All right. Explain the purpose of comparison in an experiment. Remember, when you're comparing, I don't know about you, but I have 2 older brothers, and it's so easy to compare, right? All right, some cautions here. Observational studies cannot definitely show a cause and effect relationship between an explanatory and a response variable because of confounding. Conducting a well-designed experiment is one of the best ways to prevent confounding. A treatment is a specific condition applied to the individuals in an experiment. The experimental units, which we just talked about, so this is kind of a review. are the smallest collection of individuals to which treatments are randomly assigned. When the units are human beings, they are often called subjects. Using a design that compares two or more treatments is the first step in designing a good experiment. In an experiment, a control group is a group used to provide a baseline by comparing the effects of other treatments. Depending on the purpose of the experiment, a control group may be given an inactive treatment or an active treatment. I'm just going to put another word out here. I call it maybe like home base, what you're starting with. Like home. Number 8. When there is a comparison, confounding is still possible. The knowledge that a subject is receiving the treatment may affect their response. All right, so I have this like crazy idea. I've kind of told some people for school spirit. Okay, what happens if incoming 8th graders into their 9th grade year? I think this would increase school spirit. Okay, I think some people should receive free Savannah t-shirts. And then I also have to compare it to a different group. My control group might be, well, traditionally we haven't given out free t-shirts. And then follow those students for 4 years and just find out after 4 years what's their GPAs. What do you think? What do you think? Those were my subjects, those little 8th graders coming in. All right, let's try this example here. Example number 2. Fewer calories, more life. Can reducing calorie intake increase the length of one's life? Researchers randomly assigned 46 rhesus monkeys to a calorie-restricted diet group or to a control group. So I'm going to try this color-coded. So that's one group. And this is our control group that received a standard diet. The calorie-restricted group was monitored to prevent malnutrition. It was found that the CR group lived longer on average. Explain why it was necessary to include the control group. Why do we have to have them? Well, I need to know if one group lived to 50 years old and you have anything to compare it with. You can't say one lived longer or not, right? So the purpose of the control group is to provide, remember that word we circled up here? A baseline for comparing the effects of the calorie restricted group. Otherwise, we wouldn't be able to tell if the calorie-restricted diet caused an increase in lifespan. Okay, so I'm just going to draw this. I think it was just so, why not, right? How many monkeys? 46 monkeys. So we take an SRS of 46 monkeys. You're going to do this later, and you're going to do it for your project, so I might as well just start doing it. And, well, you know, take all 46 monkeys, give them a number, put their number in a hat, pull it out. 23 of these monkeys are going to be in the calorie-restricted diet group. And 23 of these monkeys are going to have the standard diet. Call it standard. And then we're going to observe their lives, and then we're going to compare at the end. We're going to compare results, right? This is experimental design. Okay, you randomize it, you apply the treatment, and then you compare results. All right. Let's go on to the next page. We have learning target number 3 here. Let me make sure I got everything on that page. Yes, we did. Perfect. All right. Learning target number 3. Describe the placebo effect and the purposes of blinding in an experiment. Okay, so a placebo, I don't know, my word is called a fake. All right, yours will start with number 1, but the placebo effect, sorry, let me get to my notes. The placebo effect describes the fact that some subjects in the experiment will respond favorably to any treatment, even in inactive treatment. All right, so let's just say I have 2 groups, and one of these is the placebo. What did I call it? I called it a fake. So I give my kids an empty pill with water in it. And over here, the second one, I actually give them a sugar pill. And I want to figure out, you know, how fast they can run around the house, run times. Okay? So just because they think there's sugar in it, or I'm giving them some kind of, looks like candy to them, they actually might just run faster. Does that make sense? All right. A placebo, is a treatment that has no active ingredient, but is otherwise like other treatments. A double-blind experiment. Neither the subjects nor those who interact with them and measure the response variable know which treatment the subject is receiving. Okay, so I have read a real-life article on this, so... Okay, so for some people, again, they gave them a COVID-19 treatment. So they're saying, we're going to give you a COVID... I'm going to actually use blue. What color have I not used? Red. We want you to sign up for this study because we have a COVID-19 vaccine that we're trying. And we want to know if it works. Just sign up for it. And the people giving out the vaccines didn't know who was getting the fakes. And the subjects themselves, the people themselves didn't know who was also getting, if you were giving a real COVID vaccine or if you're giving a placebo, which basically means I call it a fake. They could have just put the syringe in and put in water, and then people thought, oh, I'm getting a COVID vaccination, and they would go about. What's the purpose of the double blind? So you don't know if you're actually getting the real thing, and then they can, researchers, not just the nurses or people administering, they can actually know, well, this test subject didn't get COVID, or this one did. In a single blind experiment, either the subjects don't know which treatment they're receiving, or the people who interact with them and measure the response don't know which subjects are receiving which treatment. So let's do another one. Water. I have done this experiment before. Let's just say I give you bottled water. I give you water from the tap. And, okay, it would not be ethical or right if I gave you water from the toilet. Let's say I give you water from, let's call this one, cheap bottled water, and we'll call this one expensive bottled water, okay? And I blindfold you, and you can't see, and then I give you 3 different types of water, and you're supposed to identify which one it is, right? I know which one I'm giving, but you don't because you're blindfolded. That's a single blind. All right, let's do example number 3. Is B for Botox or back pain? You may have heard that Botox, botulinum toxin A, is used for cosmetic surgery, but could it have other beneficial uses? 31 patients, N equals 31, who suffered chronic low back pain were randomly assigned to receive 200 units of either Botox or saline. So, okay, they'll tell us, so I don't have to explain it. Through 5 injections at 5 different locations in their back. The saline injection was not expected to reduce pain, but was given as a placebo treatment. So you're either given Botox or saline. Saline is just, they'll tell you, but it's just basically like salt water. After 8 weeks, 10 of the 15 Botox patients, 67% had pain relief compared to 3 of the 16, which is 18.8%, saline patients. Pain relief was defined as the patient's pain level being reduced to less than half of the original pain level. In this experiment, patients didn't know which injections they received. Explain why this is important consideration. So if the subjects were aware, they are receiving an active treatment like they really know they're getting the real thing, then researchers, or also the opposite is true, if they're getting the fake, then researchers can determine whether a patient's improvement, if any, is due to the treatment or to the patient's expectation of getting better. Which is the placebo effect. Okay, so go back to the COVID. If this person knew that they were receiving the real thing, naturally you're just like, oh yes, I'm gonna be vaccinated so I can get COVID. I can have my life as normal. I can go out. I have to do social distancing, right? There is some kind of already expectation that I will get better. But that mindset also might distort the numbers of their pain relief. Okay, go ahead and try the next page, example number 4, and then press play when you're ready to see the answers. Example number 4, let's review it all. What happens when physicians study themselves? Does regularly taking aspirin help protect people against heart attacks? The physician's health study was a medical experiment that helped answer this question. The subjects in this experiment were 21,996 male physicians. Half these subjects took an aspirin tablet every other day, and the remaining subjects took a dummy pill that looked and tasted like aspirin but had no active ingredient. Basically, they were given a placebo, a fake. After several years, 239 of the control group, but only 139 of the aspirin group had suffered heart attacks. This difference is large enough to provide convincing evidence that taking aspirin does reduce heart attacks. Why was it necessary to perform an experiment rather than simply asking the doctors whether or not they take aspirin regularly? Why do we have to perform an experiment? An experiment is needed in order to show a cause and effect relationship between aspirin and heart attacks. Simply asking the doctors whether they take aspirin is an observational study and might suffer from confounding, right? Maybe they decrease in their heart attacks because, maybe they were marathoners or because they had a strict vegetarian diet. 4B, explain why it is necessary for the experiment to include a control group that didn't receive aspirin. The purpose of the control group is to provide a baseline for comparing the effects of the treatment. Otherwise, we wouldn't be able to tell if the aspirin or something else, such as advances in medical technology, exercise, diet, cause a reduction in heart attack rates. Okay, so you have to have a comparison. And lastly, C. 4C, was blinding used in this experiment? Explain why this is an important consideration. Yes, this experiment is single blind because the subjects didn't know whether they were getting the treatment, the aspirin, the real thing, or not, or if they were given the placebo, the fake. If the subjects knew they were receiving an active treatment, researchers wouldn't know if a reduction in heart attacks was due to aspirin or the expectation of getting better, the placebo effect. For some people, this placebo effect, let me just add one more thing to it. It's kind of like, if I just put water into a syringe and said, this is the COVID vaccination. Some people might get it and they might say, wow, you said it was the vaccination. I feel so healthy. I'll never get sick. And with that type of mentality, it brings about this positive energy and just the desire that maybe you just probably you feel like you won't get sick. Okay, learning target number 1, we talked about this beginning idea of experimental design. Learning target number 0, sorry. Learning target number 1, we talked about what it means to be confounding. Is it that true variable or is there other variables in there? Learning target number 2, explain the purpose of comparison, right? We need a baseline. And then number 3, describe the placebo effect. You might get the fake, but yeah, just with the expectation, you might actually think you're going to get better. So that was lesson 3.6. We'll see you guys later. Bye.
I love math. I love math.